Welcome to Breaking News to Trading Moves.
Today, we're looking at some material that really gives a clear-eyed perspective on what's happening in the tech sector.
And it all centers on one thing, really, artificial intelligence.
Exactly. Specifically, how the acceleration of AI demand, especially in data centers, is causing this major reappraisal of value across the board.
So our mission here is to walk you through that analysis. It lays out a world where a company's success or its struggle really depends on how well it's aligned with the new hardware and infrastructure AI requires.
Precisely. The argument here is that AI demand has created a very stratified market. It's not about general growth anymore, not at all.
It's about specialized capital allocation.
Right, and this analysis gives us a clean framework. It defines three distinct categories of winners, and on the other side, three categories of losers. And it outlines the specific, often very technical logic for why each company is where it is.
That's what we want to illuminate for you. We're going to go through the mechanics of why certain sectors and companies are capturing all this investment tied to AI infrastructure growth.
And just as importantly, which segments are facing some pretty strong headwinds because that capital is being actively pulled away.
It's an examination of which technological architecture is becoming dominant and, the commercial consequences for those who either got on board early or are maybe locked into an older way of doing things.
Okay, so let's start at the epicenter of all this, the accelerant itself, the sheer scale and intensity of AI demand.
Yeah, and you can't have that conversation, and this analysis certainly doesn't, without starting with the company that's really leading the charge, Nvidia.
Their leadership seems to be the non-negotiable starting point for any of this.
It has to be. The material really reinforces Nvidia's sustained multi-year leadership in AI acceleration. And this isn't just about market dominance, it's architectural dominance. We're seeing this surging, almost insatiable global demand for their data center GPUs. And it's not a static demand, right? The material points out that Nvidia isn't just sitting on its lead. They're already rolling out their next generation, the Blackwell-powered systems. And these aren't just like small updates. They're platforms designed for the enormous scale and complexity of the newest language models. That has to give them some very high pipeline visibility.
That visibility is absolutely key. And when you look at where the demand is coming from, the document identifies enterprise AI adoption as the engine that's really driving this next cycle of growth.
So the initial boom was maybe large research labs, the hyperscalers themselves.
Right, the early adopters. Now, every major corporation is realizing they have to integrate AI models, whether it's for customer service or coding acceleration or just internal data analysis.
If that first wave was startups experimenting, this second wave, the enterprise adoption, that's a multi-trillion-dollar spending environment.
It is. When major banks or automakers or healthcare providers decide to integrate AI, they aren't just buying one or two servers.
No. They're signing multi-year contracts for massive, dedicated GPU clusters.
Correct. And this move toward AI-accelerated systems is the underlying market mechanism. It's what sorts the winners from the losers later on. We've moved beyond simple computation into something very specialized, into parallel processing.
So to understand the winners, you really have to grasp why the old architecture just doesn't meet these new demands.
You do.
So what's the defining principle here? What makes that winners list so predictable, according to this analysis?
It's specialization and the sunk cost of software. When an architecture like accelerated computing driven by GPUs and other specialized accelerators really takes hold, it doesn't just create temporary excitement.
It's more durable.
It creates multi-quarter, sometimes multi-year, guaranteed demand for every company that is structurally aligned with that technology. And for NVIDIA, this isn't just about selling a piece of hardware. It's about the CUDA ecosystem.
CUDA, that name comes up all the time. It's always mentioned as NVIDIA's moat. Why, technically, is it such a high barrier to entry that it guarantees this kind of visibility?
Okay, so think of CUDA as the universal translator and the operating system for GPU computing. Tens of thousands of specialized AI scientists, data engineers, developers, they've written billions of lines of code specifically optimized for the CUD software layer.
All the major AI frameworks, things like PyTorch or TensorFlow, I assume they're built on this.
They're inherently optimized for CUD execution on NVIDIA hardware. Absolutely.
So if a company wanted to switch to a competitor, they aren't just swapping out a graphics card from a server.
Oh, no.
They're potentially rewriting their entire code base, retuning their models, retraining their very specialized staff. That sounds like an enormous technological and financial hurdle.
It is a phenomenal lock-in effect. The cost of migration, what they call replatforming risk, it often just far outweighs any savings you might get from buying alternative, maybe cheaper hardware. And this creates that tremendous multi-quarter visibility and sustained demand for Nvidia, and by extension, for all the downstream suppliers that you need to support these highly specialized high-performance systems. That's the mechanism that defines success right now. Capital flows where the specialized demand is strongest, and right now, that is undeniably in AI acceleration.
Okay, with that foundation laid, let's turn to the companies that are actively capitalizing on this trend. The winners. The material groups them into three main categories, all benefiting from this massive, ongoing AI hardware upgrade cycle.
Right, and we have to start where the architectural revolution begins. Category A, the AI hardware manufacturers.
Their inclusion seems pretty straightforward. There's a surging global demand for AI compute capacity, and that gives strong long-term revenue visibility for the leaders in GPU, NPU, and general accelerator technology.
They're selling the specialized engines, the very things that power the AI transformation. Their revenue velocity is directly tied to AI adoption curves.
And at the very top of that list, as we've established, is Nvidia, ticker NVDA.
Yes, positioned as the primary beneficiary. The financial implication of their market position is, well, it's breathtaking. Because they control the software ecosystem, CUDA, they command not only the volume but also superior margins on their data center GPUs, like the H100 and the upcoming Blackwell series.
Let's zoom in on that financial aspect for a second.
Yeah.
The part that comes from this technical moat. If the architecture is so specialized, how does that specialization show up on their financial statements compared to, say, a traditional hardware company?
The difference is pricing power. A traditional x86 server is highly commoditized, the margins are thin.
Right.
NVIDIA's accelerators, however, are essentially bespoke supercomputing components. The material implies that their pricing power is inelastic because there's no readily available substitute that gives you the same performance per watt ratio with the required software compatibility.
So when the big cloud providers commit billions to GPU clusters, they're pretty much committing to NVIDIA's price tag.
They are, because the alternative wasted developer time and model underperformance is far more costly in the long run. This gives NVDA a very powerful, very unique relationship with its customers.
Okay, so let's move to the second company in this category, Advanced Micro Devices, ticker AMD. The material lists them as a key manufacturer, also benefiting from this trend. Now, this is where we need some analysis. Given NVIDIA's stronghold, what makes AMD a clear winner?
That's a crucial question. The analysis isn't claiming that AMD is about to displace Nvidia. Not at all. It's more that the total addressable market, the TAM for accelerators, is growing so explosively that AMD can capture a lot of that residual high-value demand.
So it's not a zero-sum game at this point.
Not yet. Cloud providers and large enterprises have a strategic imperative to diversify their supply chain. They need to mitigate the risk of relying on a single supplier.
So AMD's push with their Instinct MI series, like the MI300X, is really driven by the industry's need for a second source, even if that alternative might require some code adaptation or maybe it targets a different kind of workload.
Exactly. The material suggests AMD's winning thesis is twofold. First, as you said, diversification risk that drives procurement teams. Second, AMD is specifically targeting the inference side of the market.
Inference being the deployment of already trained models.
Correct. And that's projected to become an even larger volume market than training over time. So if AMD can capture even a fraction of that future inference spending, they make a real transition from being a server and PC component supplier to a legitimate AI accelerator manufacturer.
So their inclusion as a winner reflects confidence that the scale of demand is just too large for one company to handle alone.
And AMD is positioned to be that necessary second source of supply.
All right, now we can transition from the hardware builders to Category B, the cloud infrastructure providers, the hyperscalers. They're the essential delivery mechanism for all of this.
The logic here is simple. They're the ones investing the most capital. These companies are actively and aggressively expanding their AI data center capacity. They're increasing GPU cluster deployments specifically to monetize that exploding enterprise AI demand.
They buy the accelerators, package them up with their own services, and then sell access back to the enterprise market.
Usually on a recurring basis, yes.
Let's start with Microsoft, ticker MSFT. They're cited as a major cloud provider, dramatically increasing capacity for GPU deployment through their Azure platform.
Microsoft's position is pretty unique because of its strategic investment in and partnership with OpenAI.
Right.
That relationship lets them offer these highly integrated proprietary AI services like Copilot for business directly through Azure. So when an enterprise adopts Microsoft 365, the path to consuming AI services is almost frictionless.
So their winning thesis isn't just about selling raw compute power. It's about using AI to solidify and expand their already massive enterprise software empire.
That is the crux of it. The capital they spend on GPUs becomes a mechanism for protecting and growing their core cloud service revenue. The material suggests Microsoft views AI capacity as a prerequisite for maintaining enterprise relevance.
They're betting that integrating LLMs directly into productivity tools will drive multi-year contracts.
And that justifies the massive capital expenditure needed to deploy all those GPU clusters. They're selling outcomes, not just components.
Then the second major player here is Amazon, ticker AMZN, expanding its AI data center footprint through Amazon Web Services, AWS.
And AWS is still the global leader in cloud market share. Their strategy is really focused on providing the broadest and deepest set of options for every type of customer, from the smallest startup to the largest company.
So for Amazon, deploying more GPUs is about maintaining that market leadership.
It's about responding to the demand for scalable, on-demand compute resources. The material emphasizes that AWS's strength is in its global scale and its resilience.
They serve the broadest variety of workloads.
Yes. While Microsoft is heavily aligned with OpenAI, AWS provides platforms for a whole host of major foundation models, and they offer their own custom silicon, like the Trainium and Inferentia chips, for specific cost optimization.
So their expansion ensures they remain that indispensable provider of cloud compute.
And they capture the service revenue for both model training and the immense volume of inference workloads happening globally. They're building the AI utility grid, and that ongoing massive CapEx spend confirms their position as a winner in this monetization cycle.
Which brings us to Category C, the specialized support system, the AI-focused semiconductor suppliers. This group benefits indirectly but critically from the whole build-out by Nvidia and the hyperscalers.
Their winning thesis is rooted in technological necessity. AI hardware demands components that general-purpose computing just didn't require.
They're benefiting from demand for what? Ultra-specialized memory, high-bandwidth interconnects.
And bespoke networking chips. All of it.
Okay, this is where we need to get into the physics of an AI data center. Why does training a large language model make standard networking and memory obsolete? What creates these massive tailwinds for these specific suppliers?
The problem is latency and volume. A standard data center usually moves data north-south, from a user's machine to the server. An AI cluster operates east-west. This means thousands of GPUs have to communicate with each other all at the same time, swapping massive amounts of data in milliseconds to synchronize their training weights. If any one component is too slow, the entire cluster, which could cost billions, is bottlenecked and sits idle.
That brings us to Broadcom, ticker AVGO. The analysis notes they benefit from the need for high-bandwidth solutions for data center networking.
A VGO is critical here because they provide the advanced networking silicon that creates the AI fabric. We're talking about high-radix Ethernet switches and specialized components that handle something called remote direct memory access, or RDMA, protocols.
And what do those protocols do?
They allow GPUs to talk directly to each other's memory without involving the CPU, minimizes latency.
So if the traditional network is a crowded highway, AVGO is building the specialized, low-latency hyperloop that you need for AI traffic.
That's a great way to put it. The material implies that the demand for these ultra-high-speed, specialized networking components is far outpacing traditional networking hardware because the scale and traffic patterns of AI clusters are just completely different.
And since AVGO is a major supplier of this specialized silicon, they capture high-margin revenue directly tied to every new large-scale AI cluster that gets built.
That's it.
And finally, let's look at memory with Micron Technology, ticker MU. They're benefiting from the increased demand for high-performance memory.
This is maybe the best example of a technical specification leading directly to a financial premium. Standard server memory is DDR, double data rate memory. It's relatively inexpensive, it's plentiful.
But AI accelerators need something different.
They require high bandwidth memory, or HBM.
What's the practical difference between standard DDR and HBM?
HBM is it's a fundamentally different design. It consists of multiple memory dies stacked vertically right on top of each other. This provides exponentially wider data pathways.
So instead of moving a thin stream of data very quickly,
HBM moves a massive river of data all at once, which is exactly what a parallel GPU architecture needs. It allows the GPU to access the huge parameter sets of AI models without having to wait.
and because HBM is complex to manufacture, highly integrated, and physically constrained in terms of who can actually produce it, Micron's capability here gives them a real revenue acceleration.
Precisely. HBM is a premium component. It has much higher average selling prices and higher gross margins compared to standard memory. The analysis indicates that as the volume of AI accelerators from Nvidia and AMD goes up, the demand for Micron's HBM inventory goes up right along with it.
Making them a clear, crucial beneficiary.
They're selling the specialized fuel for the AI engine.
So there you have it. The builders, the cloud utility providers, and the specialized component suppliers. They're all tightly coupled in this architectural rotation. It's a cohesive ecosystem where the growth of one segment immediately pulls the others along.
Now we have to turn to the necessary corollary of this rotation. The losers. These are the companies facing structural challenges, either because their technology is being bypassed by the specialized requirements we just talked about.
Or because investor capital is just seeking out those more direct AI monetization plays.
Right. And the first category is facing immediate, acute pressure. That's Category A legacy server and CPU-heavy providers.
The logic here feels unavoidable. Traditional x86 dominant server architectures are losing market share and priority in CapEx budgets because enterprise spending is aggressively moving toward GPU-accelerated systems.
It's the direct zero-sum outcome of the architecture pivot.
For every dollar spent on a GPU cluster, that's a dollar not spent on a general-purpose server refresh.
Exactly. And the legacy server providers, they rely heavily on that continuous cycle of general-purpose server upgrades. The document highlights Intel, ticker INNTC, specifically because of its reliance on those x86 architectures.
And while Intel is trying to pivot into accelerators and foundry services, the reality, according to this analysis, is that their core server business, the Intel Xeon CPUs, is facing a powerful headwind.
That's the structural challenge. Historically, the entire data center was built around the Intel CPU as the primary processing unit. Now the GPU has become the co-processor, and, increasingly, it's the primary driver of compute spend.
So when a hyperscaler defers an order for, say, 100,000 general-purpose servers to instead invest in a 50,000 GPU cluster,
that massive revenue stream is diverted away from INTC's most profitable division. This creates pressure on their revenue velocity and, crucially, their gross margins. It requires them to rapidly reallocate resources away from their established cash cow.
And this pressure also falls heavily on the systems integrators. Hewlett-Packard Enterprise, ticker HPE, is listed as a major provider in the traditional server space, also facing these headwinds.
Yeah, HPE's business model is largely focused on selling and servicing integrated x86 systems to large corporations, government entities. They build infrastructure based on those traditional architectures.
And when their customers decide to prioritize spending on specialized AI infrastructure, which is often purchased directly from the big hyperscalers or boutique AI builders, HPE's product relevance diminishes.
It does.
Does the material suggest HPE isn't adapting? Or is the pace of adaptation the problem?
I think it's about scale and margin. The document suggests the margin and volume that come with selling and servicing commoditized x86 servers are much higher than the potential margin they could get from simply reselling pre-configured AI clusters, which are largely dictated by Nvidia's ecosystem anyway.
So they face a revenue contraction in their most reliable streams while they're trying to build out a competitive AI offering,
which is a period that creates severe financial strain. Their inclusion as a loser is tied to the difficulty of transitioning a massive legacy business model when you're facing rapid architectural obsolescence.
All right, let's move to Category B, consumer-only tech platforms. This group isn't necessarily failing technologically, but they are failing the current investment mandate.
That's a really key distinction. The reason for their inclusion is purely capital rotation. Investor capital is rotating away from platforms that lack a direct, tangible exposure to AI infrastructure monetization.
Investors are prioritizing companies that are building or supplying the core technology itself.
That's it. In simple terms, when the market is obsessed with selling shovels, the hardware, it stops caring as much about the efficiency of the application layer, unless, that application is at the scale of a Facebook or a Google.
And the material names, Snap, ticker SNAP, as a consumer-focused platform seeing capital allocation move elsewhere.
SNAP's value is tied to user engagement and ad revenue from their social platform. And look, they use AI extensively for filters and content recommendation, but they don't sell AI compute capacity. They don't manufacture silicon.
So when investors are looking for the best way to get exposure to AI growth, they're favoring companies that show clear control over the technology's supply chain or infrastructure.
And SNAP, despite its user base, just lacks that direct leverage on the infrastructure boom. That leads to a deprioritization by growth capital.
And it's a similar story for Pinterest, ticker PINS, which is listed among platforms experiencing the same capital rotation.
The dynamic for PINS is identical. They operate a highly successful visual discovery platform, and they leverage AI for personalization. But if you look at their cash flow, it's driven by advertising, not by the deployment or sale of specialized AI hardware or services.
So in the current environment, investors are prioritizing the certainty of growth in the infrastructure layer, the CapEx commitments of Amazon, the hardware sales of Nvidia, over the variability of consumer-driven ad models.
The material highlights that during periods of extreme technological focus, capital becomes highly selective. It favors the source of the technological revolution over the consumers of it.
Okay, finally, let's examine category C, the often overlooked but essential part of the data center: older networking and storage vendors.
Their predicament is a stark illustration of technological inadequacy. It's really driven by the physics of AI training. The reason for their inclusion is that the demands of new AI data center builds require these ultra-high bandwidth solutions, which really reduces demand for legacy storage and older networking hardware that just can't meet the new speed and latency requirements.
We talked about HBM being necessary for the GPU itself. Now we need to talk about what's necessary for the data center to feed that GPU. Why does older storage just fail in an AI environment?
It's because of the need for persistent, rapid access to petabytes of training data. Training a large model involves continuous iteration where massive data sets have to be loaded, processed by thousands of GPUs, and then the results have to be synchronized.
In traditional hard disk drives, HDDs, they're just too slow.
They rely on spinning platters, they have rotational latency that creates massive bottlenecks. Even older flash storage, which is optimized for general-purpose I/O operations, often struggles with the sustained, high parallel throughput that a GPU cluster requires.
The analysis names Seagate Technology, ticker STX, as an older storage vendor facing reduced demand in this new environment.
STX is heavily involved in traditional magnetic media HDDs. And while HDDs are still excellent for archival storage, deep storage, they are essentially unusable for high-performance AI training environments where you need sub-millisecond access.
So the capital that would traditionally be spent on large-scale HDD deployments for cloud storage is now being diverted.
It's going into specialized all-flash NVMe systems, which provide the low latency and high throughput needed to keep the GPUs running at 100% utilization. If your storage is too slow, your billion-dollar GPU cluster sits idle. And that is an unacceptable inefficiency. This rotation directly pressures STX's core product market in the data center.
And similar pressures are applied to networking and network-attached storage companies like NetApp, ticker NTAP.
Yes, they're listed as an older networking and storage vendor affected by the demand for these ultra-high bandwidth replacements. NetApp specializes in providing integrated storage and data management solutions, often network-attached storage, or NAS, optimized for traditional enterprise file serving and virtualization.
And while those systems are reliable, they weren't designed for the kind of traffic an AI cluster generates.
No, they weren't designed to handle the dense, high-frequency east-west traffic created by large GPU clusters that need specialized protocols like RDMA.
So if a CIO is building an AI data center, they can't just plug in their existing NetApp storage infrastructure. They need a specialized, bespoke solution built around high-speed fabric and parallelism.
Precisely. The material emphasizes that the uncompromising need for ultra-high bandwidth connectivity and specialized data pathways means that NTAP's established product lines, optimized for legacy enterprise functions, are often bypassed. They're bypassed in favor of hyper-optimized flash arrays and networking solutions tailored specifically for AI.
So this forces NTAP, much like HPE, to rapidly transition their portfolio.
But the pressure comes from the obsolescence of their reliable existing revenue streams. The analysis clearly shows that any technology that sits on the slower side of this architectural divide is facing a severe headwind.
So this analysis really provides a structured, detailed map of the current technology landscape. And it's all dictated by the gravitational pull of accelerated AI demand. On one side, we have the clear winners, aligned with the new architecture.
That includes the builders of the chip and the ecosystem, Nvidia, ticker NVDA, defined by its CUDA moat, and AMD, ticker AMD, benefiting from supply chain diversification.
It also includes the cloud utility providers capturing the service revenue. Microsoft, ticker MSFT, leveraging its OpenAI integration, and Amazon, ticker AMZN, dominating with scalable global infrastructure.
And that winner group is rounded out by the specialized component suppliers who meet those severe technical requirements. Broadcom, ticker AVGO, providing the ultra-high bandwidth networking fabric, and Micron Technology, ticker MU, dominating the high-margin, high-bandwidth memory market.
And on the flip side, we see the structural pressures exerted by that capital rotation. The legacy server and CPU-heavy providers, Intel, ticker INTC, and Hewlett-Packard Enterprise, ticker HPE, facing a massive architectural headwind as spending is diverted away from x86 dominance.
Then you have the consumer-only platforms, Snap, ticker SNAP, and Pinterest, ticker PINS, which are being deprioritized as investors seek more direct exposure to that infrastructure monetization layer.
And finally, the older networking and storage vendors, Seagate Technology, ticker STX, and NetApp, ticker NTAP, who are pressured by the uncompromising demand for ultra-high bandwidth and low-latency components required to keep those expensive GPU clusters running efficiently.
The entire market structure, according to this analysis, is now defined not by overall technological advancement, but by the success or failure of companies to align themselves with the specific, demanding requirements of the GPU arms race.
So this analysis gives us an important takeaway, I think, about the pace of change in enterprise IT spending.
It does. The necessary replacement of entire categories of infrastructure, from servers to storage, it demonstrates how rapidly new architectural standards, like GPU acceleration, can render established, profitable product lines irrelevant.
What this indicates is that the lifespan of reliable enterprise infrastructure is collapsing. It's forcing corporations to plan for obsolescence on a quarterly, not an annual basis, just to keep pace with the power demands of modern AI.
That's a great point.
That collapse of the infrastructure lifecycle suggests that the cost of inaction is rising very, very quickly. It makes these investment decisions not optional upgrades, but mandatory survival requirements.
Indeed.
This material is presented for informational purposes only and is not intended as financial guidance. This is not financial advice or buy or sell recommendations. This is purely the opinion of the author.